Okay, in this problem, we are trying to solve a linear programming problem graphically. We are trying to minimize or maximize z equals 3x plus y, subject to our constraints over here. Subject to our constraints that 3x plus 7y is less than or equal to 56. 5x plus 3y is less than or equal to 50. And we're going to start doing that by graphing. Do I have? So let's start by drawing some lines here of coordinate system. We also have the standard x is greater than 0, y is greater than 0 requirements as well. So we're only looking here in the first quadrant. But the way we want to do it is we want to start by graphing 3x plus 7y equals 56. And the easy way to do that is to start by looking at the intercepts. If x equals 0, if you plug 0 in for hex, you get 7y equals 56. So y would equal 56 divided by 7, which is 8. And then we also want to look at the y-intercept. If x is 0, y is going to equal 56 divided by 3. 56 divided by 3 is 18 2/3. 18.67. All right, so on my graph out here, I got to go quite a ways. Let's not count by ones. Let's count by something. Actually, let me make this a little bit cleaner here. Let me draw straight lines. So we'll get a nice vertical axis, nice horizontal. Oops, that left me the sign tool. Let me go back to the line tool. There's the line tool. Nice horizontal axis. And I want to come out to 8 on the y-axis. And 18 2/3. It's 10, 11, 12, 13, 14, 15, 16, 18, 19. So 18 2/3 would be somewhere in this area. And the line should connect those 2 points. Between those 2 points is going to give me the line 3x plus 7y equals 56. And then if we check with a test point, if I try something like 0, 0, I get 3 times 0 plus 7 times 0. That's just equal to 0, and 0 is definitely less than 56 in the original equation, so that's true. So I want the 0, 0 side of this line, so I'm looking at points down there, roughly speaking. And if I look at then the 5x plus 3y equals 50, if x is 0, y would equal 50 divided by 3. 50 divided by 3 is about 16. So this was 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's going to be 16 2/3. So 2/3 of the way there. And then if y is 0, x would equal 50 divided by 5 is 10. So I'm going to cross the x-axis here at 10. I want to draw a nice straight line connecting those 2 points. And again, if you test with the point 0, 0, you'll see that this inequality is true, that if you put in 0 for x and 0 for y, the left side works out to be 0 here, and so 0 is less than or equal to 50, so that's true. So I want the 0, 0 side of that line, and so my solution region is this area down in here. And the corner points that I want to look at, the corner points of that solution region are 0, 0, the point up here, which is 0, 8, My intersection, well, I got 10, 0, that's the easy one to read off. And then I've got this intersection point here. It looks like it's maybe, it'd be nice if I could read it off. I think it maybe is 7, 7, 5, maybe. Let's see, if x is 7, how would I do on my guess there? If x is 7, 3 times 7 is 21. 7 times 5, y is 5, that's 35. 3 times 7 plus 7 times 5. Does that equal 56? And 21 plus 35, yes, that is 56. So 7, 5 looks like it works in the top equation. If it also works in the bottom equation, I've got my solution. I've got 35 plus 15, that is 50. Yes, that does work. So 7, 5 is my intersection point. So I have those 4 points to check as my potential solution values. So what I want to do then is I want to check, we know that if an maximum occurs, it occurs at one of these corner points. So 0, 0, 0, 8, 10, 0, and 7, 5. And if we plug those into z, which is equal to 3x plus 5y, or plus y, just 3x plus y. Let me erase that 5. 3x plus 5 there. Well, 3 times 0 plus 0 is 0. 3 times 0 plus 8 gives us 8. 3 times 10 plus 0 equals 30. 3 times 7 plus 5 is 21 plus 5 is 26. And so we're looking for the maximum, and the maximum is just our largest value here. And so the maximum is 30 when x equals 10 and y equals 0. That would be the solution to this maximization problem. And the minimum, this is bounded, it also has a minimum. The minimum's here at 0, but I believe the question that we're typically looking is trying to find that maximum. So when x is equal to 10, y is equal to 0 right here at this point, we have our maximum value for z in there.